Imagine waking up one day to a planet with no invisible shield, a world where Earth's magnetic field suddenly collapses. No alarms, no dramatic explosions, but instantly, everything that protects us from space radiation disappears. This video explores what would really happen if Earth lost its magnetic field, the science, the dangers, and the long-term consequences we're not prepared for. We'll break down how radiation would spike, how the atmosphere could slowly escape into space, and how our technology would struggle to survive. And most importantly, we'll uncover what this means for life on Earth and how humanity could adapt. Earth's magnetic field works like a giant protective bubble, diverting charged particles streaming from the sun at nearly 1,000,000 miles per hour. Without it, those particles would slam directly into our atmosphere, and, for the first time in human history, the planet would be openly exposed to cosmic radiation. The first noticeable change wouldn't be on the ground, but high above us. Satellites would begin malfunctioning as radiation interferes with their electronics. GPS accuracy would degrade, communication systems would glitch, and satellite lifespans would shrink dramatically. On the surface, radiation levels would rise, especially in high-altitude regions and near the poles. Commercial flights over polar routes would face increased exposure, forcing airlines to reroute planes or protect crews with additional shielding. Earth's natural light, the auroras, would behave wildly, appearing in unusual places as radiation bombards the atmosphere from all directions. It wouldn't be instant disaster, but it would be a permanent shift in the safety of our skies. Humans wouldn't immediately fall ill, but over time, higher radiation exposure could increase mutation rates and raise long-term health risks. More importantly, the entire planet would be operating without its protective armor, vulnerable in ways we've never experienced. Earth's magnetic field doesn't just protect us from radiation, it helps keep our atmosphere anchored. Without it, the solar wind, a continuous stream of charged particles from the sun, would start stripping away the upper layers of air. This process is exactly what scientists believe happened to Mars billions of years ago. Though atmospheric loss would be slow for Earth, the consequences would be profound over long timescales. The first gases to escape would be the lightest, hydrogen and helium. Over thousands to millions of years, this slow leak could reduce overall atmospheric density, altering climate patterns and weakening the ozone layer. As the protective upper atmosphere thins, more ultraviolet radiation would penetrate, raising temperatures in some regions and disrupting global weather systems. Water molecules in the atmosphere could break apart under intense solar radiation, allowing hydrogen, the lightest element, to drift into space permanently. This gradual dehydration is something we've observed on Mars, and without a magnetic shield, Earth would be vulnerable to a similar fate. Even though these changes unfold over long periods, their impact accumulates. Small shifts in atmospheric pressure, oxygen levels, and temperature could reshape ecosystems, stress plant life, and slowly force species to adapt or relocate. While humans might withstand the immediate radiation increase, our technology would struggle far more. Power grids on Earth rely on stability, but without the magnetic field, solar storms would inject massive electrical currents into the ground. Even moderate space weather events could overload transformers, leading to widespread outages. In stronger solar events, entire regions could experience long-term blackouts as critical grid components fail and require months to repair. Satellites would be hit even harder. Without magnetic shielding, they'd absorb significantly more radiation, damaging sensors, communication antennas, and onboard processors. Weather satellites, navigation systems, and communications networks would become less reliable. Everything from global internet services to aviation traffic control could face disruptions. Even astronauts aboard space stations would require heavy shielding or emergency evacuation to avoid dangerous radiation doses. Navigation systems that depend on satellite signals would degrade, affecting shipping, aviation, and military operations. High-frequency radio signals used for global communication would become unstable, especially during solar storms. Humanity depends on a stable electromagnetic environment far more than we realize, and losing it would force massive redesigns across energy infrastructure, space engineering, transportation systems, and global communication networks. Adapting is possible, but only with enormous technological adjustments and global cooperation. Losing Earth's magnetic field wouldn't end life instantly, but it would transform our planet into a far harsher world. Radiation would surge, satellites would fail faster, and long-term atmospheric loss could slowly reshape our climate. Civilization would face the enormous challenge of redesigning power grids, shielding spacecraft, and protecting future generations from higher radiation exposure. Yet humans are remarkably adaptable. Understanding these risks reminds us just how vital Earth's magnetic field is and how unique our planet truly is. If you enjoyed this exploration, don't forget to like, share, and subscribe for more science-driven deep dives.